Hello everyone. In the previous video, we discussed the different vendors and how the devices are managed. In this video, we'll look at some of the frequently used networking terms with some analogies. Let's get started. In one of the previous videos, we discussed about switches and how the network devices like computers and printers are connected to them and how they access each other. It is quite possible that in a company there'll be different teams working and they would not want data from one network to be accessed by the other. For example, finance team will not want anyone from the other teams to access their resources. They need some kind of segregation in the network to make sure that the department network devices are isolated from each other. This can be achieved using virtual LANs or VLANs as is generally called. A VLAN can be explained with our tree and branch analogy. The branch was compared to a switch with each leaf acting like a network device. If we bring in a second branch of the tree, as shown in this picture, it is like segmenting the branch into two different branches. This is like creating two different VLANs. The network devices in one VLAN cannot communicate to the devices on the other. In this example, computer on VLAN 10 cannot communicate to a computer on VLAN 20. This is like creating two different networks. And the only way two devices in different VLANs can communicate is to go via a router. So we understand that VLANs helps in ease of administration as similar devices or teams can be grouped together and also helps in providing different treatment to each of the segments. Access Control List or ACL. An access control list is defined on the firewall. We know a firewall takes care of the security of your network. A firewall uses an ACL to regulate the traffic going through it. Let's understand this using an analogy. Consider a situation where a lot of people are waiting to enter the stadium. They're all carrying a ticket to their destination, which is the stadium in this case. A watchman has been strictly instructed to drop anybody not carrying a ticket. This rule is written into his rule book, which says anyone carrying a valid ticket should be permitted into the stadium. For each person at the gate, he checks the rule book to make sure that the ticket he carries is allowed inside the gate. The moment he comes across anyone not carrying a ticket or carrying a wrong one, they are dropped from the queue. Similarly, the firewall is like the rule book the watchman carries. In the example here, the rule asks the firewall to prevent computer A from accessing the application and to allow computer B to access the application. When the request from computer A gets to the firewall checks the source and the destination address and compares it against the rule and decides to deny the request to get to the application. In the same way, request from computer B, when it gets to the firewall, it allows the request based on the rule for source and destination addresses written in the firewall. So like we discussed before, a firewall is key to any organization's security. Virtual IP on load balancer. In the previous video, we had compared the load balancer to a call center. To give you a quick recap, the load balancer distributes the requests to an application across the different servers, just like how the calls get distributed across the call center agents based on their load. We dial a single phone number like the one shown here to reach the call center. The calls then get transferred to the different agents. Similarly, the load balancer will have a virtual IP just like the single phone number, which the devices like computers or mobile phones will send the request to access the application. The reason it is called virtual is because it is not exactly the IP of the application. The actual application is running on different servers behind the load balancer, and the VIP or virtual IP is only acting as a proxy to these IPs. Virtual Private Network or VPN. Imagine a community where everyone knows only English. They are busy talking to each other. When two friends who speak Hindi walk into this community and they start talking to each other, the folks around them do not understand what the Hindi guys are talking about or which language they are using to communicate. It sounds to them like an encrypted code. Similarly, a branch to data center connectivity sometimes happens over the internet. but sending information directly over the internet is not secure. So the data is encrypted using a virtual private network and is sent over the internet. The hackers on the internet can see the traffic going between the branch and the data center. But like the English folks were not able to decipher the Hindi language, the hackers will not be able to decipher the encrypted traffic going over the VPN. A VPN is typically used from branch to campus or data center connectivity. But a more common example is when you log in to your organization's network from home. You might have to use a VPN client on your laptop. That's another form of VPN connectivity. Quality of service. This is a very important concept in networking. It is a term which measures the overall performance of a service. When I say service, it could be voice or file transfer or even your internet browsing. Let us try to understand how QoS works in a network. In our analogy, we have a busy traffic junction. There are a lot of vehicles already waiting to cross the junction and continue their journey. We also have a traffic police who is trying to manage the situation at this intersection. He is trying to give each and every motorist a fair share of the road. The traffic is quite bad and the vehicles are stuck. At this point, he hears an ambulance approaching the intersection. He understands the priority and acts quickly by clearing the traffic in front of the ambulance and opposing traffic, such that the ambulance can navigate easily without any delay. Meanwhile, the other vehicles have to wait till the ambulance, which is a priority vehicle, passes by. Very similarly, in a network, we know there could be different kinds of traffic like internet, file transfer, voice in a network. In our example, a remote hospital and a main hospital are connected. They have a lot of file transfer like reports going on between them. They also have voice traffic traversing these links. On an ideal day, the file transfer takes up most of the bandwidth, as can be seen here. Let us say a situation arises such that a lot of emergency calls needed to be made between the hospitals. This brings in a lot of voice traffic on the links, along with the ongoing file transfer. The links are getting choked and the voice calls are getting dropped or are experiencing issues. You cannot afford the voice to be breaking up in an emergency. This is the case where voice traffic is given priority and given more bandwidth to provide a better service. The file transfer services will be given less bandwidth till the voice traffic gets relaxed. This is how QoS works. QoS helps in providing better application services when in need. Typically, the QoS is defined across the network so that any given point in time, a particular traffic is given preference when the load on the network is more. Let's take a quick recap on what we have discussed so far. We saw how a VLAN can segment your network and helps to manage the network better. We also saw how ACLs are different rules on the firewall and help to filter traffic and secure your networks. We also learned about VPN, which is about encrypting the traffic between two network endpoints like branch and the data center or campus networks. And finally, how QoS helps to provide a better application experience within the network. Thanks for watching.